I'm Claire Dooley. You're watching CHG TV, and this is the Geoengineering Report, where we identify the threat in the skies. With warming oceans, failing crops, and mass die-offs, we're now in what scientists call abrupt climate collapse. But what if this collapse is being hastened by more than just global warming? In this episode of the Geoengineering Report, we look at the accelerating breakdown of ecosystems and why official responses have been so limited. Our expert Dane connects the dots between environmental failure and the institutional refusal to act.
I mean, but these things are everything you've been talking about. These things kill people. It's like murder.
Again, it's imperative to stop and consider those in power have made no secret of their intent to thin human populations, to drastically thin, down to their stated objective of 500 million from over 8 billion. That's a lot of death. And in the case of the US population, they're not just expendable to those in power, they're a rapidly increasing liability to those in power because much of the US population is armed, aren't they? So again, people need to understand that the planet's failing life support systems can't support the human population any longer. And I know that's a very difficult pill to swallow, and people suddenly think you're an Al Gore fan. I'm not an Al Gore fan. He's a part of the problem. He's a part of the power structure. The environmental groups, the same. They're not addressing climate engineering because they're protecting their 501c3 nonprofit, as if that matters on a planet that is going down in flames. But bottom line is, mathematically, statistically, with the failing life support systems, the bees are the tip of the iceberg, absolute tip of the iceberg. The ecosystems of the planet are failing across the board. This paradigm is not going to continue. Those in power know it, and they're doing everything they can to debilitate and thin the herd before the herd panics and reaches the pitchforks and torches moment, Polly. That's exactly what's going on.
Dane, as we approach summer, what are the sort of things that we are to expect if this continues?
This summer will be like none other. We're in what's known as an abrupt climate collapse scenario. And this is not some long, centuries drawn out equation as people have been taught and trained to believe. This is the fuse that burns slowly and steadily, but when it reaches the stick of dynamite, the exothermic reaction happens and all hell breaks loose. So in regard to the thermal energy buildup on planet Earth, 10 years ago, it was equivalent to the energy contained, the heat contained in 4 Hiroshima-sized nuclear bombs per second. That's scary enough, isn't it? That's how fast the heat's building up on the planet. And anybody can research anything I'm stating. It's all there if anybody takes the time. So 10 years ago, 4 Hiroshima bombs per second. Now we're at 13 per second. Right now, based on the most recent thermal energy buildup data, the planet is warming at the thermal energy equivalent of 13 Hiroshima bombs per second. It's gone into the oceans. Oceans are superheating. We had temperatures, Polly, did you know this? We had temperatures in oceans off Florida a year ago of 102 degrees. It's killing coral, killing kelp. It's killing everything. Fisheries, fish floating up dead everywhere. Same thing's happening in freshwater. In fact, just a massive die-off in the Great Lakes right now. We're only in spring. So again, and that heat causes the oceans and freshwater to stratify, deoxygenate. Everything dies. We're there. We're going to have empty food shelves here soon. We have about 36 countries around the world right now with literally not enough to eat. Mad Max scenarios ensuing, just like Haiti. So the bottom line is people are pretending that somehow it's all going to magically work out. That's not going to happen. And I would argue there's solace in facing this storm head on, knowing you are part of the cure and not the disease. And that's what everyone needs to implement if we're to have any chance of altering this equation. Know that we're here for a reason, for a purpose. It's not an accident of fate. We have a part in this play. And it's up to all of us to play that part as best we can given our individual circumstances.
We love hearing from our viewers at CHG TV, so please reach out to us with any questions, any comments, or if there's anybody in this field that you would like to hear more from, please let us know, plug some experts and we'll try to get them on. Please reach out to us at goodmorning@CHG TV. Thanks so much for watching the Geoengineering Report. We'll see you next time on CHG TV.
We're just about ready to go into the clean room facility. We will be looking at the samples by by scanning electron microscopy. Scanning electron microscopy will provide information about the particle size distribution. We will be able to get some elemental analysis. What really this technique is for is to prioritize our samples for downstream, more advanced imaging, more high-resolution imaging, especially by transmission electron microscopy. Put on a fresh pair of gloves. We're going to start with sample number 8. This is a blank that was collected on the return flight. No flow through this filter, so this filter should be free of any particulates. I'm going to use these scissors and forceps that have been cleansed with isopropanol and then acetone, and wipe free with these dust-free cloths. These are the series of samples that we're interested in. These are samples number 9, 10, and 11. These were taken on the return flight where the plane passed through an induced cloud layer. Number 10, I believe, is the one that was passed through a cloud layer at around somewhere between 17 and 19,000 feet. I will take time to cleanse the instruments between each sampling. Preparing sample number 9, near the center. Opening it to ensure that the surface that had received the particulates is facing upward. Number 9 is completed. Now processing sample number 10. One additional sample. This blank sample was taken after the plane landed, and 3 of the samples containing actual airflow particulates had been collected. So we have one prior to the mission and one at the conclusion of the mission. Prior to imaging, these samples are coated with a thin layer of platinum. The platinum helps to take the excess charge or electrons and drain them off to the stub. And now we'll do the samples where we pass through the cloud layer.
A few little bright particles. This particle here is probably the one that we'll do the most analysis on.
So the general image that we're seeing now are the glass fibers from the glass fiber filter itself, and the bright particles or bright areas that we see are areas operating in the so-called backscatter mode of this microscope. Collects electrons that are backscattered, especially from metal center compounds. But you can clearly see the lighter and darker contrasted areas there, suggesting that it's an aggregate.
Mm-hmm. Some of the smaller particles in here we're looking at on the order of about 450 nanometers long. But there's also smaller particles in there too. So backscattered electrons, typically the higher the atomic number, the brighter the signal. That being said, what we will do is look for the bright spots and then analyze those. The glass itself does seem to have sodium in it. Looks like aluminum, sodium, silicon, calcium, potassium. Mm-hmm. So the reason that caught my eye is because it's darker than everything else. And it's got lots of small particles in it.
Yeah. And this gives us a lot of information. Again, it identifies which filters have qualitatively more materials, just, basically we see more material on it. It also gives us information about size of particles and potential for aggregates that we might be dealing with in the samples.
Barium sulfide again?
So barium sulfide is interesting. What he's doing now is just getting a high resolution image of it to see if this is indeed a single particle or if there's any evidence that there's an aggregate of smaller particles.
So really the big standout in this one seems to be iron. In this field we have one there, 2, 3, 4.
Yeah.
And I did analysis on all of them. They all seem to be pretty similar in composition.
Yeah.
Well, this is definitely made up of much smaller particles.
Yeah.
So this may be a clump of what you're looking for. We just analyzed 3 different areas. This particle seems to be high in aluminum. It's a large flake, though. And this has some silver, too.
Yeah, in terms of now the aluminum signatures that we're getting from the glass fibers themselves, this
is much bigger.
Much bigger.
So look at that.
Yeah, that's the aluminum piece.
It's easily 3x the silicon.
Yep.
And I think the silicon and aluminum are pretty similar in the glass.
Thoroughly
so here, if you look at just the glass fiber, silicon is significantly taller than aluminum. So that particle there is mostly aluminum.
Yeah.
So measuring this one right here, this is below 70 nanometers.
Right. Good. In the precipitation samples that we've seen in the past, the aluminum oxide particles that we've been seeing are on the order of 40 to 60 nanometers. So that's consistent with the size that we've seen from precipitation events. Again, these samples were collected directly from the air. There's not a lot of approaches or instrumentation that you can use to observe these nanomaterials. I mean, again, these are the sizes of viruses. And so really the only equipment or instrumentation that is appropriate for identifying these materials is high-resolution transmission electron microscopy. This allows us not only to determine the size of the particles, we can also determine the composition using a technique called elemental dispersive spectroscopy. It's done within this large microscope. So it will give us information about the morphology of the particles, the composition of the particles, and we can actually see the crystalline spacing, so the spaces of the crystals themselves. So we are talking high-resolution microscopic techniques that are really the only way to be able to observe these directly. Morphology is important because the productions of these materials are really of a constrained size range, and we've seen this already in samples that we've analyzed from other sources. American Element produces lots of these nanomaterials, and you can actually purchase them online. The size distribution of these engineered particles are quite homogeneous.
What do we get? Ooh, looks like there's aluminum. Now, what I've done is tell it to calibrate to the aluminum peak. So now what it's doing is going through each of its process times and each of its gain values and calibrating.
Oh man.
I can tell you this much. What I'm seeing right now is far superior to the last time I ran that calibration. So you see you got 2 calciums, right?
Yeah.
All right. K alpha, K beta. Right? This variant peak is probably an L or an M. Here's your major variant.
Yeah, and then you have the other to confirm. Yeah.
Correct. Variant is a triple quadruple.
It's definitely in there.
Yeah. Oh yeah.
The significance of the results is that, to my knowledge, this is the first evidence of nanomaterials collected directly from the emissions of aircrafts. This is the first time that this has been reported or acknowledged.